Hi there, welcome to this video tutorial on Leaving Cert Project Maths Strand 5. In this video we're going to be looking at the inverse of a function. We're going to see what is meant by the inverse of a function and how we find the inverse when we are either given an equation or when we're given a graph. And then we're going to look at a special case of inverse functions, which are the log and exponential functions. So the first thing we need to establish is what exactly do we mean by the inverse of a function. As usual, I'd like to start by giving you some intuition on the concept before we dive straight into worked examples. Let's say, for example, I take a straightforward linear function, f of x equals 2x plus 5. And the goal here is to figure out what the inverse of this function would look like and what it would do. So first let's just watch what our function does when we input a number. So let's say we take x to be 3. So 2x plus 5 just means we first multiply the input by 2. So 3 by 2 would just give us 6 as an output. And then we add on 5 to give us a final output of 11. Now imagine I wanted to create a new function that would undo or reverse the work of this function f. So if I was to input 11 into this new function, I would get back my original value of 3. So this backwards function is called the inverse of f, and we use the following notation to describe an inverse of a function. So in order to determine what this inverse would look like, let's rewind the animation and watch it in reverse, and note what is happening at each stage. So we're starting with our output of 11, and first we are sending it backwards through the grey box. And when it goes through backwards, we're going to end up with what we had before 5 was added, so we end up with 6. In other words, the first thing we do when we go backwards is we subtract 5. Now the 6 gets passed backwards through the yellow box, so we will end up with what we had before we multiplied by 2, which of course is our initial input of 3. So what we're doing at that stage is we are dividing by 2. So what our inverse function does then is it first subtracts 5 from the input and then it divides that result by 2. So if we wanted to write the equation of f inverse, it would be x minus 5 all over 2. And this inverse function is basically just the reverse of f, so it will undo whatever work f does. So if we were to sub 11 into that formula, we would get back our original input of 3. So the idea of a function and its inverse being the reverse of each other is just what I've got illustrated here. Except I've introduced also the idea of the composition of a function and its inverse. Because remember, when we have a composition of two functions, it just means that we are arranging the two functions in series, one after the other. And also remember that this little circle here means after. So here I have f inverse arranged after f, as you can see in the diagram. I have f of x here, which I am inputting my 3, like in the last slide, and then the output of f of x, which is 11, is being sent into f inverse. And of course, I get back my initial input of 3. So that means then when we combine a function and its inverse like that in a composition, the overall output is just equal to the input. And there's a special name for that kind of function where the output equals the input. It is called the identity map. So we can say then that the composition of a function and its inverse is the identity map. The identity map is also just written as y equals x, basically output equals input. And this is actually a special case of composition when we have a function and its inverse together, because this type of composition is commutative, so that means that the order does not matter. Here I have f of x coming after f inverse, and the same thing is happening. We're inputting 3 initially, and we get out a 3 on the other side. So really the message I'm just trying to get across on this slide is that when you have a function and its inverse, they're just the reverse of each other. And it doesn't really matter what order they come in when you put the two together.